Well, I'm going to step down in scale here, but I also am going to talk about the National Climate Assessment, and I particularly want to talk about what's referred to as the Midwest Technical Input Report, and focus primarily on the climate projections, but I'll show you a bit more about the report. So just to give you a bit of feeling about the structure of the U.S. National Climate Assessment so you can see what the role of the technical report was, is that, so I'll talk about that first. I then want to talk about the organization of the report. I'm going to talk about projections for the Midwest, and I want to acquaint you with some general terminology, give you some examples, and talk about uncertainty. And then finally, I want to talk briefly about some of the major findings of the sectoral parts of the report. So just to talk a little bit about the NCA process and structure, first of all, the National Climate Assessment was kind of governed by what was called a Development and Advisory Committee, who helped select then author teams. And these teams include regional groups where they're looking at the Midwest, the Great Plains, and so on, but also teams that were looking at sectors like agriculture, and also things that were cross-cutting, such as the Great Lakes on here. And these author teams, this initial set of author teams, were then tasked with developing short chapters written at a level that's very accessible to the general public. But they were to draw on materials that were written by then the technical input teams, which were also arranged by sectors and regions. And these teams then produced a much more detailed document written at a more technical level that incorporated both peer review and gray literature. So it's these technical reports that I'm referring to here. And the Midwest one, the responsibility for that was given to the Great Lakes Integrated Sciences and Assessment Center, GLESA. That's a NOAA-funded program out of the University of Michigan and Michigan State University. And then from Ames, Iowa, the USDA National Laboratory for Agriculture and the Environment. And we have prepared this for the assessment, but this summer actually, the report was published by Island Press, and I'm going to give you a website address in a bit. And the PDF of this book is now available free of charge, so it's a very good resource for our region on that. The sectors included in this report generally mirror those of the national assessment, and we provided two background white papers, one on climate trends and then one on climate projections. We recruited authors from experts in our region. We attempted to identify a very diverse author group. And each of the white papers or chapters of this book was reviewed by two experts in the field, and then underwent revision and to address the comments that they received. But also the Environment Protection Agency here in Chicago provided an agency review of the majority of the book. So they looked at it from their perspective on this. So I see that I somehow last night when I was practicing put two slides out of order. So let's do this one first on that. The two background reports are on the historical climate of the Midwestern area and climate projections. And I will focus today on the climate projections. The sectoral reports include on agriculture in the Midwest, written by Jerry Hatfield from USDA. Kim Hall from the Nature Conservancy looked at biodiversity. Scudder Mackey, who was working here out of Chicago, is now with Ohio DNR, looked at the Great Lakes. And then Jen Beecher and Jason Kalmbach from Michigan State University looked at climate change and energy. Steve Handler and Chris Swanson, and Chris is here in the audience, looked at, and we'll be talking here in a little bit this morning, looked at the forestry sector. Sarah Nichols, Michigan State University, looked at recreation. John Posey from St. Louis looked at impacts on transportation. And Brent Lofgren and Drew Grunwald, and Drew is here also today, looked at water resources and health. That chapter was by John Patz. So this book then covers really a broad array of sectors for the Midwest region. Okay, but let's go and talk a little bit about future climate projections. So that for the Midwest, taking off where Dawn left off. So if we look at trends, just to repeat some of the trends that you saw just a minute ago, for our region, for the most part, temperatures have increased since 1900, and annual precipitation across the Midwest decreased in the late 1800s through the Dust Bowl of about the mid-1930s, and there's been followed by a general increasing trend that continues to present. However, changes in temperature and precipitation, as Don pointed out, have not been consistent across season or also time of day. And growing season length, which is an interesting integrator of temperature, has generally increased during the last past decades here, and we have seen a general reduction in the amount and duration of ice cover across the Midwest, including the Great Lakes. Now, of course, overlaid on these trends is climate variability, and we only need to look at last year to know what we mean by climate variability, where we had very high ice trends or ice cover across the lakes. That as an example. So what we did in this climate projections white paper is that we tried to have it as kind of a standalone chapter for people who were interested in climate projections for the region. So we spent some time talking about how projections were developed, trying to give readers then an informed and nuanced interpretation of the literature on climate impacts for the Midwest, and we then summarized climate variable potential future changes for the Midwest. We incorporated as many projections as we could find and attempted to compare them. This expands upon the document that the authors of the shorter chapters were working from, Climate of the Midwest by Ken Kunkel, also available online from the National Climate Assessment. And we have actually a very lengthy table that gives then the downscale scenarios that are available for the region. So if you want to use a particular source or compare different sources. So let's talk about terminology a little bit, because you will run into this as you work with people who have been involved in developing climate projections. And because global climate models tend to have a relatively coarse scale, although the scale has become finer with time, but when we are looking at local regional impacts, we usually need information at a finer scale, a finer spatial and temporal scale, and so we need to then what we call downscaling. Do downscaling. And downscaling can either be done dynamically, which is usually meant by taking a model, a climate model that has a finer resolution and running it or driving it by the output from global climate models, or it can be done statistically, either using an empirical dynamic approach where you relate variables that you have more confidence to surface temperature or surface precipitation, or by disaggregation, by actually trying to come up with a finer resolution. So this shows the idea here that we have a large scale GCM resolution. If we do dynamic downscaling, we're going to a finer resolution. We can actually use empirical downscaling to get to a station level. We can do hybrid, where we go dynamic and then apply an empirical, but the end result are local climate change scenarios that we use then in impact assessment on this. Now, there is a very important set of dynamically downscale climate scenarios for the United States that came online a few years ago, and they're called NARCAP, the North American Regional Climate Change Assessment. This was a coordinated program of regional climate modelers across the United States, where they chose several regional climate models that are driven with different global climate models to try to look at the uncertainty here. And that table just shows then the X's what type of combinations they are available from these. And these projections are available for an historical period for comparison, and then for a mid-century future time slice under one greenhouse gas emission scenario known as the A2, which is a fairly aggressive scenario with greenhouse gas emissions increasing throughout the century. So another important term when looking at climate projections is the use of the word ensemble. We don't normally use a particular projection when we work on impacts, but instead we want a suite climate projections that are developed using different greenhouse gas emission scenarios, either the new radiation concentration pathways or the old SRES scenarios, A1, A2, B1, B2, fed into different global climate models, then that fed into different downscaling approaches, and then you can have the suite projections that can then be fed into impact models or response models, agricultural models, hydrology models, and so on. And the idea there is to capture some of the uncertainty. And generally, though, the ensemble is, if you think of these M1, M2, just referring here to models, then that range is what often is referred to as the well-calibrated range of uncertainty, or the lower bound of uncertainty. Of course, these models are really just an ensemble of opportunity, what you have available. The full range is larger than the calibrated range, but hopefully not by too much. That by the choice of models that you're capturing a good share of that. However, just because you add another projection doesn't necessarily mean that you have improved your estimate of the overall certainty, because different models actually have similar components or similar parameterizations, and so you need to be aware of that, because also that affects whether or not how you should interpret consensus of projections from different models, because remember, they're not fully independent here on that. When looking at means, it's been very, very common to just, or interpreting ensembles, it's been very common to just average the different projections, and I'm going to show you quite a number of slides next here with ensemble means, but you have to be very careful, and I'll try to point that out particularly for precipitation. Okay, so I'm going to look here at temperature, precipitation, and wind variables. And Dawn showed in one slide maps from what we refer to as CMIP-5 and CMIP-3 models. CMIP just stands for Climate Model Intercomparison Project, and number 3 and number 5, there is no number 4, okay, on that. We can talk about that in the questions. When we did our work, we had to work with the CMIP-3 on that. The CMIP-5 were just coming online, so this is CMIP-5 for looking at a number of projections from global climate models over 21, then for North America. And if you focus here in the Midwestern area, one of the things you see annual, winter, and summer is the annual increase is about 5.5 degrees by the end of the century, with a larger increase in summer, especially over the western part of the Midwest. And winter, there's a fairly distinct southwest to northeast gradient, with the largest increase in the northeast, about 9 degrees. So here then is a diagram from Ken Kunkel's work, and it's showing then these CMIP-3 models looking at the temperature difference from a baseline of 1971 to 2000, then for going out in early century, mid-century, and late century for 2 greenhouse gas emission scenarios. One that again is fairly aggressive, the A2 increasing throughout the century, and B1 where we actually seen some stabilization. And you can see how different these are by the time we get to the end of the century, so the choice of greenhouse gas emission scenario can have quite an impact then on your interpretation of the future climate. Now, over on the right, though, are these NARCAP scenarios, the ones from the regional climate models. And one of the things that you can see that by mid-century that the projected increase is relatively uniform from the NARCAP scenarios across the area, but you can also see fairly substantial differences between season, with much less projected change in spring compared to and fall, but especially spring, and very little spatial gradient in these two seasons compared to then here winter and then summer. And winter, very interestingly, you can see larger increase suggested for the northern part of our area, where in summer the largest increases are projected for the southern part of the area. So this gets at this idea of spatial variability on that. Now what we tried to do is compare these two projections that were being used as kind of the baseline for the National Climate Assessment with the good work that's been done in our area by climate scientists to look at regional climate change. And for example, there is a group out of the University of Wisconsin called WICCI, W-I-C-C-I. It's Wisconsin Plus State Government, and they have developed scenarios for Wisconsin. And some of the things you might see is that there are some differences between their scenarios, which are statistically downscaled versus the dynamically downscaled ones from NARCAP. For example, here the projected annual change is somewhat larger for the wiki ones, and in particular when we look in the the winter time here, with theirs showing the largest change in the northwestern part of Wisconsin, which is not what we see in NARCAP. Don and one of his former students, Catherine Hayhoe, have been working on climate scenarios themselves, and Catherine and colleagues have a set of scenarios from CMIP3 models for the Great Lakes area, but they are quite using a higher and a lower emissions. But note that for winter, they also agree with NARCAP and that they show greater warming to the north of the region, but in the summer, greater warming to the southern part of the region. Okay, so consistency there. Of course, temperature thresholds and indices are important, especially warm days. And so the NARCAP scenarios suggest considerable spatial variability in these. And if we take a look at the projected change by mid-century and the annual number of days of temperature, maximum temperature greater than 95 Fahrenheit, we can see that that increase is greatest here in the southern part of the region. This is the current climatology, so the increase is large where this number is already large, so presenting potential very large hazard for the southern part of the area. Much smaller change in the northern part of the area, really fewer than 5 days in the northern part of the Midwest. Now here what we have is a projection for a station in Michigan. This comes from work that we've done at Michigan State University, and it shows here the projected change as being on the order of 5 days by mid-century, about larger, around 19 days by the end of the century. But I wanted to show you this because here's a use of ensembles. So you can see the range, the uncertainty here. And then here is what the wiki is showing, okay? And I have a 5-minute warning. So heat waves, then looking at the number of consecutive days, and we can see that we have, again, the projected change much larger to the south than to the north. And if we look at our different projections for the length of the frost-free period, expected to increase fairly uniformly across the area, and the Pilius scenarios are in agreement with that. On that, one thing though about temperature is that some of the work we've done at Michigan State University on freeze risk is showing quite a bit of uncertainty, and that is that for perennial crops, for example, the amount of heat accumulation you have at the time of last spring freeze affects how sensitive the buds are to freeze damage. And about half of our scenarios suggest that there would be more heat accumulation, more sensitive buds at the time of frost damage, and the other half said less. So highly uncertain there. For precipitation on this, as Don showed, this global climate models are in considerable agreement that winter and spring precipitation in our area should increase, but the models are in much less agreement, with almost half the models suggesting an increase in precipitation, the other half a decrease of precipitation in our region during summer. So that's very, very uncertain here. On that, if we look at the CMIP3 models, we can see that there is across the Midwest quite a spatial difference, with projected decreases in the southwest and increases in the northern part of the area. But look at then these areas here, or the monthly maps, and particularly summer map, a decrease here in the southern part of the area, but little change shown in the NARCAP scenarios. But that remember, it's an ensemble mean, and you have to interpret it very cautiously. It doesn't probably mean that there's a little change of precipitation. It just means the projections are uncertain, with as many increasing increases as they're showing decreases on here. And downscaled scenarios, again, we have them from Catherine, we have them from Wiki, and they are all fairly consistent that we have high uncertainty in the summertime for precipitation. But they are more consistent in that the number of days with heavy precipitation should increase, and fairly uniformly across the area. Okay, now wind, when we come to wind, a lot of uncertainty here on that. So it's at this time, there's little evidence to suggest a change in wind resources. Okay, so I'm going to skip this and just point out that the projection table is in the MTI, in the report, the Island Press book. on that. And I wanted to also point out to you, because this is something that questions I receive a lot when I work with the press, is that they're very interested about all the certainty about the climate projections, and they forget that there's also uncertainty associated with the impact models on that. And some of this uncertainty with the impact models can be as large as the uncertainty surrounding the climate model. So that might be with agriculture models, hydrology models, population models, economic models. And Drew might talk a bit about the uncertainty with Great Lakes water levels, because that's a wonderful example of how you have to take into account, okay, on this. So when I practiced last night, I must have talked faster, so I'm going to skip a bunch of slides on here, but I just want to again remind you that there's agriculture, biodiversity in the Island Press book, coastal, energy, forestry, Chris will talk a bit about that, outdoor recreation, transportation, water resources, and health on that. And you can find this, again, freely available in PDF format at the website given here, and which will be made available to you. It's a wonderful resource for the area, because it just really focuses on it, gives the technical background to what is in the shorter Midwest chapter in the National Climate Assessment, so they work together well. Okay. So.